Section 7.2 on applications of exponential functions. Now, exponential functions appear in application problems a lot because a lot of things in nature grow exponentially. So here's some examples of those phenomenon. One is population growth. So usually you're letting t be time. Time usually is like maybe in terms of years after a specific period or something like that. And then P naught, this number in front, it's like P naught times A of T here. This number represents the initial population. It's what you get at time 0. So if you plugged 0 in for T, A to the 0 would be 1. You'd be left with however many, whatever this number is. And so basically this function model is you put in a time, and then this function spits out what the population is at that many years or whatever the time is after the initial measurement was taken. Also, things decay exponentially, such as radioactive material. So when you hear the word half-life, that's the amount of time it takes for a material to decay to half its previous mass. Usually we use A of T to denote the amount of material at time T after the initial measurement was taken. This coefficient out front, A0 or A naught, represents the initial amount of substance. So you might be measuring that in terms of grams. And then you have some base number to the power T, where T is time, maybe in years or even sometimes minutes after the initial measurement is taken. Interest is also an amount that tends to grow exponentially. So if you're given a specific principal, the amount of money that you put in to the account at the beginning, R is the rate, usually the annual percentage rate. T represents time, usually in years after you make that initial investment. And then if you have interest that compounds multiple times a year, then the number N would represent the amount of times per year that the interest is compounded. So then what you get out from this, put in a specific time, and the output value would be the amount of dollars that the amount that your investment is worth. So that would be how much money, the principal plus any interest earned, the total amount. All right, so in the next few videos, we'll go through some examples, some example problems. Some of these examples, you have that the function is given to you, and then you just have to kind of interpret the function by answering some questions. Other examples, the ones that are a little bit more difficult, require you to create your own function. So that's where you have to do some mathematical modeling. Those are generally the more difficult ones because you have to do a lot of problem solving there.